जाएगा फिर हमारे यहाँ पे, यहाँ लिख के आएगा गो लाइव। अब गो लाइव जहाँ किए ऑटोमेटिक स्टार्ट होगा। नहीं है, साउंड बंद कर देते हैं क्या, उससे दिक्कत है? हेलो हेलो। ठीक है, ये जा रही है, देख रहे हो ना ये वीडियो, जो ये दिखेगा और ये हेलो हेलो जा रही है। ठीक, अब यहाँ पे बंद।
So, good afternoon to everyone. I am Vardhan Goyal from Electrical Part 3, and I welcome you all to the first workshop of CODIGO 2023. So, today we are going to discuss some basic topics regarding competitive programming and which will be very useful in data structures and algorithm questions as well. So, the first topic we are starting with is time complexity and space complexity. So, are you ready? Okay. Yeah. So time complexity. Time complexity is basically the time taken by the algorithm to run as a function of the input size. In competitive programming or in general programming, we do not consider actual time as the time complexity or the time taken by the algorithm to run. It is the number of operations that the program performs and which is a function of the input size. Fine. So there are different notations which we can use to denote the time complexities. There's omega notation or sigma notations, and one of them is big O of n notations. In general, we use big O of n notations only. So, and one more important point that you should remember about the O notations is that it gives the time complexity in the worst case. Now, what do I mean by worst case? So, anyone has any idea? I think we should make the session little interactive. Otherwise, I will only be speaking and you will be listening. So, can anyone explain what is the worst case time complexity? If anyone has studied time complexity or anything, no one. Yeah, correct. Yeah, correct. Like you can give any example or anything like which everyone will be able to understand in a better way.
For example, for sorting an array, if the array is
Yeah,
like sorted in the descending order and you wish to sort it in ascending order, that
yeah,
will take the maximum amount of time. So that is the worst case for this.
fine. Or in simple terms, if I explain you, suppose you are given an array which consists of ones and zeros, and you need to convert all the ones to zeros. And the question asks you like how many operations you need to perform. So you will say it's O times number of count of ones. But but the worst case will be like if all are ones, then the worst case time complexity will be O of n, which is the length of the array which has been given to you. So is it clear? Okay. So we always take the worst case complexity in the big O of n notation. So, and similarly in the space complexity as well. Fine. So let's move to the next slide. Yeah. So one more important thing is that when we analyze the time complexity, so if we get a general expression in terms of n is the input size which has been given to us. So we create a function and we take the highest degree term to and take it as the time complexity of the whole program. And we ignore the constant terms or anything. Like one example is given here, like 3n cube plus 5n square plus 2n plus 7. So in this case, the highest degree term is n cube. And so and we'll ignore the constants as well. So the time complexity of the program which perform these many operations is O of n cube. Fine. Okay. Now see, depending on the program, we have different time complexities. So we can have O of 1, which is constant time. Then we can have O of log n. Then we can have O of n, that is linear time. Then O of n log n, n square, 2 raised to the power n, and n factorial. So if we discuss about the different curves here, so the lowest one is of the O of n log n. O of log n. Fine. So if suppose the number of operations are, number of elements are 90, then you take log of it, it will be a very low value, so around tending to 0. Fine. So then you will take log of it. Then if you have O of n operations, that means it's a linear graph. So this is the one for it, the linear. It's varying linearly with the y and x are varying linearly. Fine. Then you have O of n log n. So if you multiply these two curves, then you get this above one curve. So that will be O of n log n. Similarly for the n square, you know that what is the curve for the n square, that one. Then for 2 raised to the power n, the next one to it. And similarly for n factorial, it's just a steep, very steep curve. Fine. So in this way, we can see like the programs can generally have these values of the time complexities, these functions only. Okay. Any doubts? Fine. Let's move on. So now we have some examples to discuss the time complexity. So in the first case, what is like, I have already mentioned the answer I thought I would be asking you, but okay. Can anyone explain how the time complexity is O of n in the first case? Yeah. Yeah, fine. Correct. And can anyone explain like what is the code for? Code for, like what is the code doing? If you are given, suppose you are given an array A, now what is the code actually doing? What it is computing?
Adding an element the element at the ith index will
Yeah.
be equal to the sum of the element at the I minus 1th index and the ith index of array A.
Yeah. So what does it represent actually? What is prefix of I? If it represents the sum of the I till the I minus 1th index and then the sum of the ith index, then what it is representing? Anyone? Is it representing the prefix sum like of all the elements up to the ith index? Is it okay? Any doubts? A of I is the array which is given to you. Suppose you are given 1, 2, 3, 4. Then prefix of 0 will represent the sum up to the 0th index. We are using 0-based indexing in this, okay? Generally, the code is in 0-based indexing only. Fine. So, and now let's move on to the second one. So here, you can see like there is a one loop which is going from I equals to 0 to I less than n. Then the second loop is going from j equals to 0 to j less than n minus I minus 1. So in this case, can anyone explain how what is the time complexity and how? Just don't see the below part if you can ignore it. Hello, am I audible? Yeah. So, anyone? No one? Yeah, please.
इसमें तो बस उसको अरेंज कर रहे हैं एक एरे है तो
Yeah.
असेंडिंग ऑर्डर में अरेंज कर रहे हैं तो अगर I 0
Ascending or descending, like, or both?
नहीं एक ही है
First, you tell me about time complexity, then we'll talk about what the code is doing actually.
I अगर 0 है तो I 0 को मतलब फर्स्ट वाले टर्म को सेकंड से कंपेयर कर रहा है अगर बड़ा है तो फिर स्वैप कर दे रहा है तो
Yeah.
अरेंज हो जाएगा फिर जो लास्ट वाला है एलिमेंट वो हमारा अरेंज हो जाएगा तो n-1 फिर लूप
Yeah, that's okay.
तो I 0 पे n-1 ऑपरेशंस होंगे फिर I equals to 1 पे n-2
Very good, yeah.
लास्ट के हमारे अरेंज होते जा रहे हैं तो
Yeah.
फिर उसको ऐड कर दिया
And what you are doing in each operation, like if the next element is smaller, then you are swapping it. So basically, it will arrange in the ascending order. Is it okay? Anyone is having any doubt like how it's arranging in ascending order? You can ask. Fine. Okay. Let's move on. Yeah. So this is our next one. So what do you think about this? Many of you must have seen this code as well. What is it? Have you heard about binary search? So like what it's doing and time complexity.
It's searching for a particular like number.
Yeah.
Binary.
And what is the time complexity?
It is not linear, it is just
Yeah, that's obvious, but how and what?
because it is not searching each and every element in this every time
Yeah.
reducing the search area into half.
Half. So like initially if it was n, then it became n by 2, the search space. So basically till n reduces to 1, you are doing the operations. So in short, if you can see like till n divided by some 2 raised to the power k becomes less than 1. So if you take this side, so it will be n is less than 2 raised to the power k. So if you take log n, so this k will be, this will be log 2n. So the number of operations are log n. Is it visible? Fine? Okay. And this is the next one, this one, time complexity. We haven't mentioned the code here, but there can be a suitable one which we can put. It's good that the solution is on the next page for this one, at least. Anyone? Do you want some time or we can proceed?
They can tell the answer as well as.
Hmm. Okay, 20 seconds more, then we'll discuss because we have time constraints also, that's why. I think now we can proceed. So, anyone? Anything?
For every means I first one, it will be n2, n3, n, so we will add
So, what will be the expression?
n square.
How? Like what expression you are getting?
Means for if I equals to 1,
Yeah,
then it will be n operation.
n operations, fine.
If I equals to 2, then n operation.
How many operations? N by 2, right? Then n by 3. And this will continue to n by n. Right? So you need to find this sum. So it will be like this. Fine? And now how you can find this sum? We cannot evaluate this sum so easily, so we'll just found the upper bound for this sum. So I can say that this expression is less than equal to this, suppose 1. This I am keeping 1 by 2 only. This 1 by 3 I am replacing by 1 by 2. Then we have here 1 by 4, 1 by 5, 1 by 6 and 1 by 7 and so on we have. So here what I am doing, this 1 by 4 I am replacing everywhere. This is 1 by 4. So it's going like this. So this you can see that this is 1, this is again 1, this is again 1. So similarly this will continue till log n times, like the previous I explained how did this came log n. So it will basically be the sum of this expression will be less than equal to some log n and multiplied by n. So this time complexity will be less than log base 2n. And here in coding we take the base respect to 2 only. If it is not mentioned, it is by default that you should take it base 2 only. Fine. So this is the time complexity for this. Okay. So here we have mentioned that only, that you can see later. And the last one is the most easiest one. This is simply O of 1 only. We are calculating the sum by using that formula. Okay. So only linear operation, constant time operation. Yeah. So next, this is an important thing. Like when you practice competitive programming and on platforms like Codeforces, you always get some time constraints and some space constraints. So in general, we take like in 1 second, the number of operations performed are little less than 10 raised to the power 8, which you can see on the first line that is mentioned, 10 raised to the power 8 operations per second. Fine. So many a times when you are solving the problems, you look at the constraints and you get an idea like how to solve the problem and what could have been the time complexity, and then you are sometimes better able to achieve to the correct solution. Fine. So like for if n is 10 raised to the power 18, then if you see, you can do, if you do O of n operations suppose, then it will take how much time? Like for 1 second it takes 10 raised to the power 8 operations, but the limit is only till 1 second only. So you cannot perform more than 10 raised to the power 8 operations, but here you are performing 10 raised to the power 18 operations. So you cannot do that in the given time limit. Fine. In general it's 1 second or 2 seconds only. So for such cases you need to find a code or algorithm which runs in log n times, because log n of this will be something around 60-61. Fine. So similarly for 10 raised to the power 10 you can find this O root of n algorithms, because it will be around 10 raised to the power 5 operations per second. Then similarly for 10 raised to the power 7 the linear time algorithm will run, because it's under 10 raised to the power 8. Then for 10 raised to the power 6 is n into n log n. Similarly for 10 raised to the power 5 this, and so on you can see. Fine. Okay. Okay, now the time complexity portion is over. Now we are coming to the space complexity. So it is analogically to the time complexity only. It's the measure of the memory consumed by the operation, and similarly as a function of input size as in the case of the time complexity. So here if we consider the first case, here we have created 3 variables and assigned them some values. So the space complexity is simply O of the constant, so O of 1 only. Then if you are creating an array, then that means you are creating n memory locations. So you need n spaces, so that's why the time complexity is O of n. Then here in the third case, it's a 2-dimensional array. So the time complexity, it's a matrix type, so you need n square. So the space complexity is n square. Similarly, this is just n and m, so it will be n into m. Fine, that is the matrix size. Yeah. So this you need to remember, like the int data type takes 4 bytes in general, but it depends on the compiler also how much memory it stores. But in general, we take 4 bytes. Then long int takes 8 bytes, short int takes 2 bytes, carbool int 80, and this all takes 1 byte. And regarding the memory, as compared to like in the time complexity case, it was 10 raised to the power 8 operations in 1 second. Here it's 10 raised to the power 7 integers you can store in 40 MB, and generally in context it's given around 250 or 1000 depending on the platform. So you can create arrays. Fine. And one important thing to note is, like, you can create the declare an array of 10 raised to the power 6. If you declare it inside the main function, then it will give an error. You cannot declare it locally, you can declare it globally, but with the vector you can declare it locally as well as globally. And the issue behind this is, like, if you create an array in case of in the locally, then the stack memory overflows. Like, I don't think, like, you might have heard about stack memory, so you can just surf through net and explore about it. And but you should remember this, that never declare an array inside the main function or locally of size greater than or equal to 10 raised to the power 6. Fine. So this was about time complexity and space complexity. Now we'll be moving to STL, and STL is a very powerful tool in C++, and it provides a variety of functions, one-line functions, and you can perform very big operations which require many lines of code in just one line. Those are inbuilt in this library. So it can be divided into 4 components: algorithms, containers, functions, and iterators. So let's go one by one through each of them. So we'll start with algorithm. So we'll first start with the sorting part. So this sort function sorts your given, I think I'll show you in the editor as well. Is everything clear till now? Any doubts you can ask? So let's discuss about the sorting operator. So here you are given an array and you need to sort it. So by using STL you can directly sort it. So the function for it, you will write like sort function, then you'll write the first this iterator, which is ARR, and then the ARR plus n. Fine. So this will sort your array. Like, so here ARR is the first iterator which is pointing to the first element, and ARR plus n is the iterator which is pointing to the next element to the last element. That is a superficial one actually. The last iterator is not the one pointing to the last element, it's next to the last one. Okay. But when we write the code, we consider the last iterator to be that only when we are writing it. So in this way you can sort the array. Now if you will print the array, you will find it to be sorted. I think there is some issue with the input, but I think this will manage it. So no problem. So suppose we are giving the array size to be some 5, and then so this we have given the array, and now if we run it, so you are getting this sorted array. Okay, and if you are declared a vector, now how can you declare a vector? So it will be in vector actually is a dynamic array, so you can pre-declare its size also, and you can there is no need to declare the size also, that you cannot declare the size as well, and you can push back or you can pop the elements from there. That will be discussing few in the future workshops, but yeah, we are using it, so I'm just telling. Achha, sorry. I'm actually in a different habit. So in the vector, the iterators, the first iterator we represent by v dot begin, like if the v is the vector name, and the iterator which is pointing to the next to the last element is v dot end. So if you need to sort this vector, then this is the syntax you need to write. Okay, and if you want to sort it in the decreasing order, then you can use a comparator function here, which is greater int, and then it will sort in the decreasing order. So in this way you can sort it quickly with one line of code. Okay, then we'll move to next part. Next is the reverse. Similar to the sort, if you just change this word sort with the reverse, then the whole vector or the array will be reversed. Then for the maximum element, in the similar way, the syntax, the inside syntax is similar. If you write this max underscore element, then you will get the iterator which is pointing to the maximum element. And if you want to get the value from the iterator, like if you are given the iterator, then you need to put a star before it, so that we have put. Okay, then similarly for the minimum element, then the count will give you the count of the occurrences of some number x. Here actually there is a misprint, like here it should be x as well, comma x. Then you will get the count of the x in the given vector or array. Then this find operator will find and will return the iterator which is pointing to the first x which is there in the array or the vector which you are applying this. Then you have lower bound. Now lower bound, you will get the internal implementation of this in the third workshop where they will discuss about the binary search, but in short if I will tell you, lower bound returns an element which is greater than the first element in the array or the vector, which is greater than or equal to some desired x, suppose x you are taking, so which is greater than or equal to x, and upper bound gives you greater than x. Fine. So in this way you can take lower bound, but an important point to keep in mind is that you can apply lower bound or upper bound only when your array is sorted, and that you will realize when you will go in the when you'll attend the third workshop. Then you will know like why we need to do this. This is just the one-liner function which we are telling you. Then you have next permutation. Next permutation I'll just code it and tell you. So vector is a dynamic array actually. Now in array you have to pre-declare its size, and then you assign the value to different positions. But in a vector, what? Yeah, there is no need to initially declare the size of the vector. You can push back the elements and its size is variable actually. Reduce, yeah, you can pop the last element only. You can remove in O of one time, but you can remove in between elements using the erase function as well, but it takes O of n times. That's not worth. Okay, and details about this we'll discuss in the next slide, vector in detail. So this is about the sorting. Yeah, next permutation I was telling. So next permutation returns a boolean value if the next permutation of the given array exists or not. So suppose I'll take the permutation as change it. I'm using a do-while loop. So I'm just changing the input to something different so that it will be easy for you to understand. Or let me take 3, I think, otherwise it will be huge. So see, now the next permutation returns you the boolean value true or false if the next permutation exists. Now in the input I given 1 2 3. So when you are running this do while loop, it will first check that if the next permutation to 1 by 1 2 3 exists or not. So the next permutation is 1 3 2. So it returns true, and if it exists, then it prints also. So then the next time we have printed this 1 3 2. In a similar way, you can print all the permutations. So these are lexicographically in the order. Fine. This is the lexicographically smallest, then greater, and similarly. Fine. So in this way you can, and similarly there is previous permutation. Like if you change this next to PREV, then it will return the previous permutation to the current permutation. Fine. So this was about next permutation. Then we'll move to next slide. Yeah, so now the next part of STL is the containers. So first one is the vector. So vector, as I already said, you can, this I'll show you again. This time I am not declaring the size of the vector initially. I'll just push back the elements. So now you can see, like, I am taking an integer input, then I am pushing it back in the vector. So in this way also you can create a vector. Now you can see the difference. Like here the size we haven't declared of the vector initially, and we are pushing the elements, and it's dynamic in nature, the size. So now if you will print, then you will get the whole array. Fine. So this is about the pushback, and this takes O of one operation. Then similarly, if you want to remove the last element, you can use v dot pop back. I'll just write up for printing also. As you don't know the size of the vector, so the function is v dot size. It returns you to the size of the vector. Okay, so I'm using it, and then I'm printing the vector. So suppose I pop the last element. So the way to the syntax is like this: v dot pop back. This will erase the last element of the vector. So now if you run it, see, so now we have taken 1 2 3 as the input, and we have popped the last element 3, so we are getting only 1 and 2 in the vector. So this you cannot do in the array, this you can do in the vector. So this is the main difference. Fine. So similarly there is a v dot erase function. In this you need to give the iterator. Like suppose if you want to remove the element at the ith index, then you can give v dot begin plus I, which is the iterator of the ith index. So this will erase the this ith index, and then you will again print. Then you will find the suppose you erase 2, then only 1 will be there in the this vector. But this takes O of n time, so it's not worth that much. But the pop back option is worth because it uses only O of 1 time. Fine. And similarly you can insert in vector. So these are some functions, and for more functions you can refer GFG. There you'll find, and their implementations as well. And you can just hit and trial all the cases in that. Now the next one is set. So set is a very useful container, and here you store unique elements in sorted order. I'm repeating, unique elements in sorted order. So like, and the time complexity for insertion in a set is O of log n, and deletion also log n, and whereas in the vector it was O of n, and here it's O of log n. So that's a very much big difference because the log factor reduces n to very much small value. So that is the benefit. And also one point to keep in mind, that it stores unique elements only. Then if you insert some same elements, it will keep only one copy of it and remove the rest of the copies. So that was about set, and you can erase and delete. Let me show you the implementation. So the syntax for it is, so this insert function inserts the element in the set, and if you want to print, then you can use here. You cannot iterate in the set like on indexes like you iterate in the vector or the array. Here you need to iterate in the form of the iterators only, because its internal implementation is such that which you will study in future. So that's why you cannot iterate on indexes. That is a bit drawback of it, but yeah. Sorry. Okay. There is again some issue with this. Let me change its order so that you will be able to learn that it's in sorted. See, now you're getting the sorted output, and this insertion operation which we have used here, so this will take log n times. And if you need to erase an element, then you can use s dot, I'm erasing here. If suppose you want to erase 1 from it, then you can use s dot erase 1. So this will erase 1, and now if you run it, so you will just find 2 and 3 in the output. Is it okay? So this will also take log n time, whereas in the vector we notice it took O of n time. So that is the benefit. And this is about set, and this is the iterator which is pointing to the first element, this to the next to the last element. Okay, and the next one is this one. So the next is multiset. The difference between set and multiset is only that in the multiset you can store in the set you can only store unique elements, but in the multiset, where does the code vanish? I think it's yeah. In the set you can only store unique elements, but in the multiset the elements may not be unique. So but one thing, all the operations are same, but one thing you need to keep in mind, like suppose I'll show you. So now I'm running it. I'll change it to multi-set also. Yeah. Sorry. So now one thing to note is that like I erased one from the multi-set, so both the ones are removed in this case. But suppose there could be a case like you want to remove only one of them only. Then you need to first use the find operator, the find function of set. Now s dot find will also return you the current elements. I'll just show you. Like if you write s dot find here, so if you write s dot find here, this will return you the iterator of the first one which is here in the array, in the set, and it will erase only that one which the iterator is pointing to. So only one copy of one will be erased. So that only you need to keep in mind, because sometimes you erase one, then all the ones are erased, but you only want to erase one of them. So that creates debugging issues sometimes. So that is only the main difference. Rest all the operations are same and fine. So let's move to the next one now. Next is the map. In the map you can store key value pairs, like there is a key value and there is a mapped value. So suppose you create a map, show you here also the it keeps the elements in the sorted fashion according to the key value, and the insertion and the deletion operation takes O of n time only. So suppose we created a map. Yeah.
Suppose you want to delete the second one, then in that case.
Second one, then you need to then store the index also of that one basically. Suppose now how you are defining the second one, which is coming the second time, right? So in that case what you can do is, like you can create a pair of vector and you can push the elements. Suppose you are first finding one's indexes from the iterations, and then when you find the iterator, you can use that iterator only to erase the one. You can iterate on the set, you can find the iterator which is pointing to the second one. You can keep a count variable, some variable c, like if the count is 2 now, like that you have iterated, you have got already one, then you can use that iterator and erase it. Okay, so yeah, I want to map. So suppose in map you can have two different data types of the key values, they need not have the same data type. So suppose you are creating, suppose in map of this one, you are storing 1, then in map of 2 you are storing 2. Sorry. So in map the benefit is that you have two values, like one is, this is the key value and this is the mapped value, and when you will print map of 1 you will get the value 1, and the insertion and the deletion operation again takes O of log n times, and the printing is similar to that the set one, it.begin and it.end. In that way you can print, and rest is like one more way you can use, like it's a shorter way. You can use auto takes the data type automatically, you do not need to declare the data type, so you can print it like this, map, and then you can print this it.ff, not ff file at first, and then you can this is the key value it.first, and the next is the mapped value, that will be the mapped value. So in this way you can print it. Oh, sorry. So here you're getting 1, 1, 2 and 2. In this way you can print. This is a short way. Otherwise you can use that map.begin and it is not equal to map.end, which I showed you in the that set 1. So
Show them how to access the values and compare to the key.
yeah. So suppose you are having this, if you know the key value, then if you want to print like what is denoted by map of 1, so you can just write map of 1. In this way you can print this value. So map of 1 is 1. In this way you can print the mapped value of the particular key, that is 1. So this is about map. And analogically to the set you can create multi-map which can have different key values. Then about the stack, the stack is follows the last in and first out operations. So in this it's like a stack, like you are pushing an element which it goes to the top of the stack, and then when you pop the element it is removed from the top. That is what it about. So like if you want to create the stack, so I'll create a stack. This is the syntax to create a stack. Here you can give the data type anyone which you wish, anything. And suppose I am taking an integer input. Yeah. 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 Yeah, I'll show you. See this one. So here this auto, it you do not need to declare the data type of IT. It will automatically assume the data type. So this IT basically represents the pointer which is pointing to the that key value pair. Okay, and if you want to access that pair's first value, then you need to. So you know about pairs. Are you aware about how to declare a pair? You don't know about that. Okay. Huh? Yeah, it will be covered next, but just in short I'll tell you so that you will be able to understand. So if you want to declare a pair, so you can go like this. Pair holds two values together. So suppose this pair, then this is how you declare a. Actually, that code is already inbuilt in this, that you do not to think. It will automatically iterate in the map from beginning to the end, the iterator. This is a shorthand notation which I told you. Okay, so this iterator will point to the pair. Then if you want to print the first element of the pair, then you can use p dot first. Then it will print 1. For p dot second, it will print 2. Okay. So in that way, I have printed id dot first, id dot second. Okay. Yeah. And id dot second is printing the mapped value. Then the next word is stack. So I'm creating a stack here now. About the stack you will also learn in detail in the workshop 3. So you will be more clear after that, and I'm just quickly explaining it. So you can use the push operation to push an element at the top of the stack. You assume it like a stack, like a literal stack. So in this way you can push the element into the stack. S dot push, it takes O of one operation, and if you want to pop an element, so the last element which you pushed in it, that will be popped first. So that's why it's last in first out. Fine. And similarly, Q is just opposite, first in, first out. Here, as you can pop the last element in push, you can in Q you can pop the first element. And then we have next one is priority queue. As a top also, okay, fine. If you want to print the top element, then you can use this as dot top function. It is also a one operation. So in this way you can print it. It will print the last pushed element into the stack. So at first you push 2, then you push 3, and at last you pushed 1, so it's printing 1. Fine. So that is the topmost element of the stack. Now if you want to pop it, then you can pop it. You can use s dot pop, and then you can again print the top element. You can check what is the top element. Okay, I didn't give spacing. Actually, it's printing this one. I'll comment it out. These two slashes will comment your code. That will not be executed by the compiler. So now you're getting 3. Fine. So okay, that was about stack. Similarly about queue also, you can remove the first one. Then in priority queue, that we'll discuss. No, sorry. Priority queue keeps your elements in the descending order. The first element is the largest one, and so it's the decreasing one. So how you need to declare it? So in this way you can declare your priority queue, and the operation is similar, like using the push operation you can push an element into it, and when you will print it, then you'll get it in the descending order. Fine. And you can, when you will pop, it will pop the first element, the largest element at the first. Fine. And if you need to declare it in a way like this first element is the smallest one, then what you can do, you can change the syntax a bit. You can add here vector int, and then you can add this greater comparator. Now comparator also you will be discussing now after a few minutes. So in this way, now this priority queue will act as a main heap. Main heap is when the first element is the smallest and the last one is the biggest one. So in both way you can use this priority queue, and the operations of push and popping is O of 1 only. Fine. So that's about priority queue. These are actually different data structures. In problems you sometimes require set, sometimes require priority queue. According to your necessity you can use these things. And the last one is the DQ. DQ is doubly ended queue. In this you can push the element at the beginning also, pop the element from the beginning also, push the element at the end also, and pop the element from the back also. So both side you can play, and in O of 1 only. And one more special thing I'll show you, just a second. I'll just create a DQ. So in DQ, if you need to push an element at back, then you'll use push back. So in this way you can push back an element A, and now if you want to push in the front, then you will use push front. So suppose we are pushing at back also and front also, then I'll add push, or I'll show you this at last. So in this way you can push the element at the back, and this you can, suppose you want to push 5, then this will add the element at the first position, and then if you are printing it, now in queue, priority queue, in stack you need iterators to print it, but here you can go similar to the array only. So you can use this thing, int I equals to 0, I less than the size of the DQ. So that's the benefit of using it. and you can print this DQ. What? No, you cannot do the same thing. That's what I'm saying. In that you need iterators, like I showed you in set. In set you cannot iterate like this. You fix the size and you iterate from the first index, because its internal implementation is such that. Okay, so that's the restriction. But in DQ you can do that. So in this way you can print all the elements of DQ. So like I'll run it. Oh sorry. See, so originally we pushed 2, then we pushed 3, then 1 at the back, and then we pushed 5 at the front, so it's coming at 5 here, and then we printed it. So we are getting the desired output. Fine. And if you want to pop, then you can use dq.pop back. It will pop the last element, and if you want to pop the first element, you can use dq. Pop front. So in this way you can do these two operations, and so these 4 operations take O of 1 time, and you can print it like this. So this is the benefit of it. So now it was earlier 5 to 1 3, then you pop the first and the last element, so only 2 and 3 are remaining. Fine. So this is about DQ, and then erase and all operations, those operations take O of log n time only. And so that's about the container part. And now I like to call Ashwini to continue. Thank you.
Hi everyone, my name is Ashwini Sisodia. I am a student of Electrical Engineering Part 3 and I will be just continuing the workshop further. So our next concept is about iterators. Iterators are used to point at a memory address of STL containers. They are primarily used in sequence of numbers and characters, etc. They reduce the complexity and execution time of the program. So actually जैसे आपने pointers पढ़ा था C लैंग्वेज में, ये कुछ वैसा ही है, बस फैंसी नाम दे दिया कि STL के जो मेमोरी जो यूनिट्स हैं उनको बस इटरेटर्स कह देते हैं, और जो जैसे डेटा स्ट्रक्चर जैसे सेट है, मैप है, उनका जो मेमोरी यूनिट्स हैं उनको एक्सेस करने के लिए अलग से एक कॉन्सेप्ट बनाया है इटरेटर्स. सो इसमें वी कैन अगर अपने को जैसे कोई डेटा स्ट्रक्चर उसमें जो पहली पोजीशन पे कोई है इटरेटर, कोई जैसे पहली पोजीशन पे कोई वैल्यू है, अगर उसको एक्सेस करना है, उस इटरेटर को लाना है, तो वी कैन यूज सम फंक्शंस लाइक बिगिन एंड एंड. एक्चुअली एंड डू नॉट point to the last value but to a position which is just next to the last value which is contained inside the data structure. So let me show you in the editor. Okay. So we can have a dummy array here. So I hope you guys got how we can declare array. So we can also declare it in this way, like manually, in telling it each of the elements. And then we can also define iterator for it. The syntax is little different for defining an iterator. It is like this double semicolon and then typing the keyword iterator and then giving the variable name. So then we can assign this variable ptr to any of the iterators inside the array, this vector named arr. So at first we can assign it to the very first iterator of the vector array. So we can do this just by assigning this like this. And if you want to know the value which is present at that particular iterator, we can use a star symbol in front of it to use to dereference it. And let's run it. Just delete it. So see, the first value of this vector was 0, and using the iterators we have just dereferenced it, and we got a value 0. And in the similar way we can also get the last value. Just so if I run this same program, so will it be correct or not? Will it produce the value 4 or not? It will produce 3. To get the value 4, what should I do with the variable PTR? I should increment it. No, actually this is what I told you. The the end function does not return the iterator to the last value of the data structure, but it returns the position which is present next to the last element. Means to the right, outside the data structure. Yes, -1. We will do -1 here. Let's see now. That's this 4. And we can also use this pointers, this iterators inside the for loop, like air dot begin ptr equal to plus plus out just so you got it or not? See that at the condition for stopping the loop is ptr not equal to arr.end. So as soon as it will be equal to arr.end, it will stop working, and till then it will have printed all the values of the array or the vector actually. So let's move on to the next slide. So our next topic is about pair. A pair is a simple container which consists of two elements or objects. The first element is referenced as first and the second element as second, and the order is fixed. मतलब लेफ्ट वाला हमेशा फर्स्ट होगा और राइट वाला हमेशा सेकंड होगा. ऐसा नहीं हो सकता कि राइट वाला फर्स्ट हो जाए और लेफ्ट वाला सेकंड हो जाए, ऐसा कभी नहीं होगा. इसका मेन यूज जब आता है जब हमको दो डिफरेंट टाइप के डेटा टाइप्स को एक साथ एक एंटाइटी बनाना होता है मैनिपुलेशन करने के लिए, या फिर कभी कभी जैसे अपने को कुछ इंडाइस चाहिए होती है, तो जब यूज होता है पेयर्स. तो इसका मैं आपको इम्प्लीमेंटेशन दिखाता हूँ. हाँ वो हटा रहा हूँ. अच्छा ठीक है. To define a pair, we just have to type in the keyword pair, and then there it will come the first data type, and then the second data type. Okay, so actually do not do like that, it is just for telling. So I will do a realistic one. We can make a pair of int and string. We can make a pair of int and a vector. Or anything else which you like. Like we can also make a pair of pairs. Okay, so let's just see how to initiate the pair. Like we can initiate the parts, the first and second part of the pair P1. So there are two ways for it. We can just initiate each of them separately. Like this can be 56, and P1 dot second can be any string like CODIGO, and we can just also print it. P1 dot second. So when we will run it, let's see, we have a correct result here. There is also another way to initiate the pair. We can also do it in a different way. So we can do it like make pair. We can use a function named make pair. So first value is this and second value is run it. We get the same output. We can the pair can also be, we can also make a vector of pairs. And we can just push back some pairs in it. Like that. So if we want to access each and every element of the vector of pair, we can use this type of syntax, the for loop, and so do you guys still have some confusion about this type of for loop? Actually it is a different type of for loop. So इसमें क्या होता है कि ऑटो, इसमें तीन पार्ट होते हैं. मतलब इसमें एक तो ऑटो की जगह कोई डेटा टाइप भी हो सकता है, जैसे इंट, स्ट्रिंग, कुछ भी हो सकता है. जैसे तो अपन ने ऑटो लिया तो ऑटोमेटिकली ये एक्स को पेयर बना देगा, क्योंकि वी पेयर वेक्टर है पेयर्स का. ठीक है. तो जब ये इसको ट्रेवर्स करता है तो हर बार एक्स उस वैल्यू को अज्यूम कर लेता है. जैसे 1 2 है और 4 9 है, तो पहली बार में वो 1 2 का अज्यूम करेगा. फिर अज्यूम करने के बाद उसमें जब x ने जब 1 2 को अज्यूम कर लिया 1 और कॉमा 2 को, तो x डॉट फर्स्ट क्या हो गया 1 हो गया, x डॉट सेकेंड हो गया 2, तो बस वैसे ही प्रिंट हो रहा. गॉट इट? सो लेट्स गो टू द नेक्स्ट स्लाइड. Here are some links where you can learn STL and videos. So here is another important part, sorting with comparator function. Lot of people are confused in it. So we will just try to do it very clearly. हाँ, किसमें वेक्टर में नहीं होगा. देखो अलग अलग डेटा स्ट्रक्चर की अलग अलग यूटिलिटीज होती हैं, उसके हिसाब से उनको यूज़ किया जाता है. जैसे वेक्टर की यूटिलिटी है पुश बैक पॉप बैक, मतलब उसका मेन काम है कि उसका जो साइज है वो बढ़ाया जाता है और कम किया जाता है एंड से. डेक्यू का काम अलग है, डेक्यू अलग तरीके से यूज होता है, उसको दोनों तरीके से दोनों तरफ से मैनिपुलेट करने के लिए बनाया गया है. तो उसमें एक्स्ट्रा फीचर्स है पुश फ्रंट और पॉप फ्रंट. ठीक. So for the time being, this is the code for a basic sorting. So can anyone explain me how it is working? What the loops are doing and how it is sorting the array?
I think you have seen it somewhere. So today have you seen it?
Okay, then actually what it is doing is that it is starting from each of the indices and looking for a minimum from that index to the last one, and it is just swapping to that index. Then it is moving to the next index, and like that. It is just sorting all of them. Yeah. So let's move on to the next slide. So can anyone tell me what is a comparator? What feeling do you get when you listen to the term comparator? कंपैरेटर को सुन के कैसा फील आता है, मतलब क्या करता होगा ये? तो कंपैरेटर कुछ नहीं होता, बस एक फंक्शन होता है जो अपने को अलाउ करता है कंडीशन डिफाइन करने के लिए दो चीज़ों को कैसे कंपेयर किया जाए. जैसे इंटीजर्स में तो बस बड़ा है छोटा है या बराबर है, लेकिन स्ट्रिंग्स में अपन बहुत तरीके से कंपैरिजन कर सकते हैं. जैसे नॉर्मली अगर करेंगे तो उनका एक एक कैरेक्टर होगा कंपेयर, फिर उससे पता पड़ता है कि कौन सा लेक्सिकोग्राफिकली छोटा है कौन सा बड़ा है. लेकिन हम इसमें कंडीशन बदल सकते हैं. तो इसमें अपन कर सकते हैं कि कौन सी स्ट्रिंग बड़ी है उसको पहले रख दो, कौन सी स्ट्रिंग छोटी है उसको बाद में रख दो, या फिर उनका फर्स्ट कैरेक्टर से ही होगा उनका जो कंपैरिजन है. तो बहुत सारे तरीके हैं, कुछ भी कर सकते हैं अपन इसमें. तो बस यही था, बस इसमें और मतलब इसमें इस स्लाइड में और स्लाइड में बस एक ही चीज़ चेंज करिए. यहाँ पे जो कंडीशन थी vi ग्रेटर देन vj, इसको बस कंपैरेटर फंक्शन से बदल दिया और कंपैरेटर फंक्शन में अपनी एक कंडीशन डाल दी है. ठीक है, गॉट इट. This is the way to write the comparator function for objects of user defined classes. ये ज़्यादा यूज़ नहीं होता पर जानना अच्छा है. अगर कभी आगे क्लासेस बनाया आपने तो उसमें आपको कंपैरेटर यूज़ करने का ज़रूरत पड़ेगी तो आप ये यूज़ कर सकते हैं. So now we will discuss about the sort function. Vardhan has already discussed about it. Then we will just see an extension to it. So the algorithm used by sort is intro sort. वैसे किसी ने सुनी है क्या एल्गोरिथम इंट्रो सॉर्ट? नहीं, मैंने भी नहीं सुनी थी. Intro sort being a hybrid sorting algorithm uses three sorting algorithms to minimize the running time. क्विक सॉर्ट, हीप सॉर्ट, इंसर्शन सॉर्ट। तो मतलब बहुत एडवांस एल्गोरिदम है, अपने तो ज़्यादा काम ज़्यादा आएगी नहीं, लेकिन सी प्लस प्लस में ये यूज़ होती है और लगभग इसका लीनियर टाइम होता है, एन लॉग एन से भी कम। Simply putting, it is the best sorting algorithm around. It is a hybrid sorting algorithm, which means that it uses more than one sorting algorithms as a routine. तो ये जो सिंटैक्स है ये तो आपको अभी तक पता पड़ ही गया होगा, वापस देख लेते हैं। Just leave it. We can start. To sort it, we just need to put the beginning iterator of the vector and the end iterator of the vector. So then for printing so see, it is sorted now. So ये तो आपको पता ही है। फिर अगला देखते हैं। तो डिसेंडिंग में कैसे सॉर्ट करेंगे, इसका जो मेथड्स हैं इसमें वी हैव टू मेथड्स। तो पहला तो है पहले सॉर्ट कर लो फिर उल्टा कर दो, तो उल्टा कर देते हैं। So see, it is now sorted in descending order. So we can also do it using inbuilt comparator, जिसकी अपन बात कर रहे थे मेनली। तो उसके लिए बस अपने को कुछ नहीं करना, इस सॉर्ट में ही एक इनबिल्ट कंपैरेटर यूज़ करना है, जो अपन ऐसे पैरामीटर की तरह पास कर सकते हैं। फिर so see, using this also we got a descending order. तो ये तो हुआ स्लाइड तक। So we can also write our custom comparator functions other than the default ones which are present in the C++ standard template library. So to do so, there is a way to write a comparator function. So comparator function is always a boolean function, and it will क्या हुआ? It will receive two parameters which will be of same type of the data type of that vector. Like if you have a vector of strings and you want to operate upon it, so the comparator function will also have a two parameters, input parameters, which will be of type string. So instead of this greater int, what we can do is we can define a comparator, our custom comparator function को पास कर सकते हैं हम यहाँ पे, जो जिसका नाम मैंने रखा है CMP, और इसमें जो डेटा टाइप्स होंगे वो इंटीजर होंगे, क्योंकि अपन ने जो वेक्टर है वो इंटीजर टाइप का है. इसमें दो नंबर लेंगे. तो अब आता है इम्पोर्टेंट पार्ट. तो ऐसा आप अज्यूम करेंगे कि नंबर 1 नंबर 2 से पहले आएगा एरे में सॉर्ट करते वक्त. मतलब हम चाहते हैं कि नंबर 1 पहले आए नंबर 2 से. तो उसकी कंडीशन पे हमको ट्रू रिटर्न करना है. जैसे अपने को अभी चाहते हैं कि डिसेंडिंग ऑर्डर में हो, तो फिर नंबर 1 बड़ा होना चाहिए नंबर 2 से, तभी वो पहले आएगा. सो वी विल जस्ट रिटर्न if number 1 greater than number 2, return true. ऐसा करने पे अच्छा हाँ ओहो So see, we have defined our custom comparator function for descending. For ascending as well, we can also do here. We can just reverse the sign and it will be sorted in ascending order. See. So is there any confusion in comparator function, how to define it and other things? You can ask it now. Is it clear? हाँ. फिर उसने कुछ रिटर्न ही नहीं किया, तो मतलब हाँ. अब अगर जब कंडीशन नंबर 1 जब नंबर 2 से छोटा होगा तब वो ट्रू रिटर्न कर रहा था. तो मैंने अगर जब वो कंडीशन नहीं आई, वो नहीं आई, तो फिर वो रिटर्न ही नहीं किया, मतलब उसने कुछ, इसलिए. हाँ मतलब हाँ वो तो बात सही है, लेकिन वो फिर एम्बिगुअस क्वांटिटी रिटर्न करता है, कभी ट्रू कभी फॉल्स. तो उसको डिफाइन करना पड़ेगा, या तो ट्रू या फिर फॉल्स. एक्चुअली जब मैंने ये लिखा था अपने कंपाइलर में, तो इसी रिटर्न टू पे ही सही आ गया था, लेकिन वो कंपाइलर टू कंपाइलर वेरी करता है. तो मेरा जो कंपाइलर था वो बाय डिफ़ॉल्ट बोल जो है वो फॉल्स रिटर्न करता है. इसमें डिफरेंस है ऑनलाइन आईडी में, इसलिए. सो प्रायोरिटी क्यू और सेट में किस तरीके से कंपैरेटर फंक्शन लिख सकते हैं, वो उसका थोड़ा डिफरेंट है तरीका. उसका कोड यहाँ है, यू कैन लुक इनटू इट. So we can also do this using comparator. Given a vector of strings, sort the vector elements on the basis of size of string in descending order. If sizes are equal, sort them in lexicographically smallest order. So we will have a vector of string first. इसकी कोई कंडीशन बताएगा क्या लिखेंगे कंपैरेटर फंक्शन में? कोई हाथ खड़ा करके बोल सकता है, मतलब सबसे पहले क्या चेक करेंगे फिर क्या? ओके,
साइज के डिसेंडिंग ऑर्डर में और फिर एसआई कोड के असेंडिंग।
ठीक है। चलो ये तो हाँ वो स्लाइड में है वो। हाँ मतलब जैसे अपन ने पहले बताया था कि जो क्लासेस होते हैं डिफरेंट डिफरेंट, उसमें अलग तरीके से कंपैरेटर फंक्शन लिखा जाता है। वो कहाँ गया ये? तो इस तरीके का यूज़ होता है सेट में कंपैरेटर डिफाइन करने के लिए। इसका बाद मेथड लगभग वही है, बस इसमें बस ऊपर क्लास CMP पब्लिक करके कर दिया है, बस थोड़ा सा डिफरेंस है। ओके, ये ठीक। हेलो, आवाज़ आ रही है? सो लेट्स डू इट। सो हम चाहते हैं कि साइज ऑफ स्ट्रिंग्स जो हैं वो डिसेंडिंग ऑर्डर में आए, मतलब सबसे बड़ी स्ट्रिंग सबसे पहले आए और सबसे छोटी सबसे बाद में आए। अगर वो बराबर हैं लेंथ में तो फिर जो लेक्सोग्राफिकली छोटी है वो पहले आए और जो लेक्सोग्राफिकली बड़ी है वो बाद में आए। तो इसका कोड ही लिख लेते हैं। स्ट्रिंग so number one dot size. If you don't know, the dot side function returns the size of the string, उसकी लेंथ रिटर्न करता है। is not equal to, मतलब दोनों की जो लेंथ है वो बराबर नहीं है, तब अपन चेक कर रहे हैं। तो तब क्या होना चाहिए? जो बड़ी लेंथ है वो पहले आनी चाहिए, है ना? तो रिटर्न नंबर डॉट साइज is greater than number dot size. Else अगर दोनों की साइज बराबर है तो लेक्सोग्राफिकली कंपैरिजन होगा, तो उसके लिए अपन सिंपली लिख सकते हैं नंबर 1 इज लेस देन नंबर 2। बस इतना सा करना था, बस हो जाएगा। ओके, सो इसमें और उसमें बस ये फ़र्क है क्योंकि उसमें मैंने इफ़ यूज़ कर लिया था तो वो फॉल्स को नहीं चेक करा था। इसमें डायरेक्टली ये एक्सप्रेशन ही ट्रू है या फॉल्स अपने आप रिटर्न करेगा। ओके, दिस इज द जस्ट लाइक इट इज सिमिलर टाइप ऑफ यू कैन डू इट। दिस इज अ गुड वन। इफ समवन कैन टेल मी द ट्रिक। अच्छा ठीक है, कितना हो गया? Okay, so these are some practice problems about STL time complexity sorting with comparator function. You can do it in free time. Okay. क्या? हाँ भेज देंगे। ओके। Okay, so this is a culmination of the workshop. So see you next time. अगली बार अपने फ्रेंड्स वगैरह को लेके आना. आज अटेंडेंस बहुत कम थी. बढ़िया बढ़िया.
अकाउंट लॉग आउट करूँ क्या? स्ट्रीम स्टार्ट कर दूँ यहाँ पे OBS पे. बीच बीच में OBS चलाना बैकग्राउंड पे. OBS स्टॉप स्ट्रीम.